Nitrate. Okay. Oh, we already did this, didn't we? Okay. Denite. We've nitrified, we've converted our ammonia to nitrate, which is what we don't want that. Why? Algae, blue babies, all the bad stuff. Okay, to denitrify, we convert this NO3, this nitrogen and 3 oxygen molecules to nitrogen gas. How do we do that? You want me to get real scientific on you? They fart. That's legitimately what happens. All your bugs are, if you give them oxygen, right? It's like eating candy. You're throwing a bunch of Snicker bars in the water. They can take that in all day. It's easy to eat. They don't have to work for it. Oxygen is no different. Just a bunch of free sugar. Take it right into the cell wall. You shut the air off. Now they don't have any Snickers. What do they got to eat? The most readily available thing, which is probably nitrate because it's nitrogen and 3 oxygen molecules, right? It's the most easily absorbed into the cell wall. So, I shut the air off. Denitrification. What happens when I shut the air off? Nitrate is absorbed into the cell wall, and I got to convert that to gas now. I don't know about you guys. If I have a whole bunch of sugar, a whole bunch of prime ribs, and then they take the prime ribs away from me, I sit around for a little bit, get the bubble guts, then what? Nitrogen gas, baby. Okay. So in simple, shut the air off. Nitrify, get that ammonia to nitrate, shut the air off, get the nitrate consumed in a cell wall, let them off gas. When there's not enough free oxygen to consume, they will select NO3 as a form of food because it's soluble, easy to get into that cell wall. So when I say, when they don't have enough free oxygen, you guys, we were talking about DO earlier, right? Everybody says, oh, yeah, I got to have your DO to 2 to nitrify, down to 0 to denitrify. And I talked about ORP. So, anybody have an ORP probe or familiar with an ORP probe? Good. What level do I nitrify at? Greater than how many millivolts? Say that again? Greater than 50 to 100 millivolts of electrical current I can nitrify. That's an aerobic condition. Now, denitrify, where's that level? Say that again?
Positive 50 to negative 50 is primary and lower.
And lower. Positive 50 millivolts to negative 50 millivolts. Why are we talking about electricity when we're talking about poop? Right? Nobody cares. It's a much more accurate scale to measure your nitrification and denitrification. Now, did anybody talk about fog this last couple days? Okay, so when I say volatile fatty acids, you guys think of fog, right? For the most part? Does anybody think of anything else? What is it? Deer waste. Deer. Oh, beer waste. I was like, Jesus. I love the deer hunt, but man, beer waste, yeah. So VFAs, most people think of grease. Now, if you run your ORP down to negative 250, negative 350, what happens? Fermentation. What happens with fermentation? We produce volatile fatty acids. So now the simple way to do that would just be to dump our grease interceptors into the wastewater plant, right? Instead of creating VFAs for my other bugs to do work, just dump grease traps into them. Simple, right? Not even close. You dump a grease trap into the front of your A basin, you got more problems than VFAs. You probably ought to be looking for a new job. The VFA production is for a whole other set of bugs that we won't talk about today because I get real nerded out there, and then you guys will be, Friday, be like, Dave, just shut up. VFA production happens at that methane fermentation stage if you run that DO down too far, or the ORP down too far. Now, if you just run a DO probe in your process, you'll never know where that ORP level is. Your DO could be 1.5 during the aeration cycle. You shut the air off, it immediately drops to 0. Good, denitrified. But are you hurting yourself because you're driving that DO even further? Your ORP is really low and you're fermenting. Now what happens, pre-treatment folks, what happens when I ferment? What happens to my pH? Drops, right? Alkalinity usually dumps, pH goes down. Now, what happens when you've got heavy metals and a dumped pH? It precipitates. What happens to your biosolids when you precipitate too many freaking metals? You can't get rid of them. Now, is this all kind of making sense why this tall, nerdy guy is talking about wastewater plants? You guys directly affect what I do every single day. If you guys allow your local limit to be X for zinc or chrome or whatever it is, I need to know that. Right? Because if I don't know if I'm fermenting and dropping my pH and my alkalinity, all of a sudden my chromium from one plater in town is being precipitated, and it's not bound in the sludge in the mixed liquor or the reactor, it's going straight to my digester in concentrated form, and then I'm spinning the sludge out with a centrifuge, the water's going back to the front of the plant, and the sludge is being concentrated with high levels of chromium. Then I take my 503 samples for land application of biosolid, and I fail. Now, who's done local limits evaluation for your plant? Has everybody noticed that biosolids portion? You got to know what your biosolids are to develop your local limits. Now, who's in charge of making sure your biosolids are in good shape? Is it you guys? Is it the pre-treatment folks? What's that?
Biosolids coordinator.
Well, forget that guy.
Oh, okay.
The operators, thank you, whoever said that. Your operators are the ones that determine what your biosolids concentration is based on the process that they do. So now are we seeing more reason why we should be hanging out with the pre-treatment folks, with the operations folks, with the collections folks? If you got a water plant, probably hang out with them too. Okay, we done with D-Night? Everybody kind of grasping it? It's making fart bubbles? Okay, you guys are tired. Headworks equipment. Let's go back to the front of the plant just for some visual stuff. Step screen, rotating perforated plate. You guys have all probably seen one of these. Grits and rags. You guys have all seen that, right? You guys, part of your job is to make sure that we don't get too much of that, right? Part of your job. Headworks process control, just normal stuff, right? We want to make sure the same thing you guys in the pre-treatment world are worried about. No weird pH swings, no temperature swings, no big stuff, no oils, no greases, stuff like that. Primary clarifiers. Who's got a primary clarifier? Okay. Who has a primary clarifier that doesn't run very good? No? It runs pretty good? No idea how it runs? Settle out the poop, skim off the grease off the top, and let the rest of the water run through the plant. Pretty easy, right? What happens with a primary clarifier if your pre-treatment program isn't working right? It's upset. If you're letting weird flows go into a primary clarifier, it won't settle right. There's all sorts of things that can go wrong with a primary clarifier. And you're talking big plants. Primaries are usually on 3, 4 MGD and bigger. You know, Metro. Who's the guy from Metro? How many primaries you got? How many? And what's your flow rate? 130 million a day. 3 primary clarifiers. Now, every drop of that 130 million goes through those clarifiers, right? What happens if I have a huge fog load one day? The what?
Knocked offline.
They are knocked offline. Now what? Now my primaries, my preliminary treatment. Headworks is still running. Preliminary treatment's gone at the primary clarifiers. And now I'm running everything straight into an A basin, right? Not good for a big plant. I mean, you are violating permit limits within minutes. This is where, so primary clarifiers are mostly there to reduce the BOD and TSS. And how do I reduce BOD and TSS with a clarifier? Sinkers and floaters, she says. Charity knows all about the sinkers and floaters at Fort Collins. That's actually very accurate. The sinkers and floaters. You know, a turd that floats, what's wrong with that one? Too many beers. The DO's high, right? Come on. What do I mean by EQ basin? What does that mean for a plant? Bingo. Everybody hear that? Offset your high flow periods. Basically, all your flow runs into a tank so that you don't get these weird influxes and surge of flow coming through your plant. Now, if I have an EQ tank at Longmont, they just put in a new EQ tank here a few years ago. I think it's 2.5 million gallon tank for a 12 MGD facility. In the event that I have an industrial load come through and the pre-treatment people are like, yeah, we got them. What happens to my EQ tank? It's still in there. For how long? Based on your MCRT or detention time? We don't know. So EQ tanks are a huge, huge benefit for a city or a town or whatever that has very weird diurnal flows. But from a pre-treatment perspective, they can be a nightmare. Because something came in at 2 o'clock in the morning, the plant is upset, it's still in that EQ tank. We don't know how to get rid of it. We don't know where it came from, we don't know how to get rid of it. But the plant operators have to figure it out. They're just basically throwing things at the wall, hoping it sticks, right? So as a pre-treatment person, this is a big deal for you. Because this is your place where you can do that composite sample before that EQ and after that EQ. It came in at 2 a.m., it left the EQ tank at 2:15, but it's in there for 30 hours. You have a chance to actually collect a little bit of that. Was it toluene? Was it chromium? Was it fog? What was it? Was it diesel fuel? You have a chance to play with it. Here's a primary clarifier. A lot of them have roofs on them. And why do we have a roof on a primary clarifier? Odor, because they stink like hell. It's raw sewage in a giant tank. Primaries, like Charity said, the sinkers sink, the floaters float. This keeps the fog out of your primary process. Aeration basins, we've talked about this a little bit. Aeration basins are different types and sizes. There's a billion different variations of it. This is where the oxidation of ammonia happens and conversion of nitrate to nitrogen gas happens depending on the plant. How many people just nitrify? Okay. How many people denitrify? Nitrify and denitrify. Do you do it all in one tank? Where do you denitrify?
We have an
Anoxic basin, right? So this is your big plants. They've got numerous tanks to do certain work. Are the bugs the same in the aeration basin as your anoxic tank? Absolutely not. You're creating an environment for those bugs to do the work that you want them to do, right? So your bugs in your anoxic selector are usually your lower level stuff. Amoebas, filaments, stuff like that. They're just basically just trying to survive. They get into the aeration basin, that's where your big stuff's growing. So you got to create that environment. So there's a bunch of operational design options. Extended air flows into one big tank or a series of big tanks and flows out based on how much flow is behind it, right? So this is where you'll see your aeration basins kind of do this all day. You know, people get up at 6 a.m., take the shower, take their dump, flows come up, go back down around noon, come back up around dinner time, go back down until, the next morning. That's kind of how an extended air plant works. They see that kind of flow running through the plant. Step feed. Step feed is not real common, but they're pretty cool. Basically, step feed is just a giant or multiple giant tanks, and you feed the influent in at different areas. You're feeding your bugs to create an environment for them to do a work that you want them to do in certain areas of the plant. Following me? Oxidation ditch, racetrack. Just round and round and round and round and round and round and round until the gate opens and lets it out. There's a ton more. So, process control. Reactors where most of the instrumentation will live, your online analyzers. Systems will operate the reactors on DO and ORP. Probes in the reactors, there's nitrogen, nitritax, there's nitrate, nitrite, phosphorus, there's all sorts of probes that people have in their process. As a pretreatment person that sits in the office at the pretreatment building, did you know that the plant had these? If you didn't, you should go see those guys. Because that DO drop, immediate DO drop at the front of an A basin, is an indicator of something that's not sewage. So you guys should have these emails, maybe even have access to their SCADA, so you can see the trends. You know, trending for a wastewater plant operator is all about consistency. Every morning when you go in at 6 a.m., 7 a.m., whatever it is, that trend better look like it did the day before. And even though you don't run the plant as a pretreatment person, you still see that every day. Looks the same, looks the same, looks the same. One day you walk in and there's a weird blip. That's a phone call to the operators. Hey, I noticed a blip. What's that all about? Sometimes they have an answer, sometimes they go, we're still trying to figure out what happened. Then that's your turn to go, let me look at my side. Who is on the radar right now for dumping something? Who dumped something recently? Who's mad at the pretreatment program because we just fined them or gave them an NOV? Things to think about. Talk a little bit about pH and TSS and phosphorus. Trending, we talked about that. Okay, extended aeration system. So I know it's hard to see in the back, but if you can see the picture, does the white foam look normal? See the white foam kind of looks like Coke, like you just poured a Sprite or a Coke? Does that look normal? You're an operator, love it. That is not good. If you have that at your plant, you have operational things to worry about. And it may be a pretreatment issue. It may not be a pretreatment issue. When I walk into any plant, before I even look at data, sight, smell, taste. Come on, Charity, you want a kiss? Not really the taste part, but sight and smell. I walk into this plant, I immediately know the FDM's off. Immediately, just from the foam. Then I start smelling it. Smell like sewage? Does it smell like dirt? Smells like dirt, we're probably okay. If it smells like sewage, we don't have any bugs. F to M, food to bug ratio. Food is sewage, bug is biomass. White, crispy foam like that is usually from when you started up a plant. Have anybody ever heard people talk about seeding a plant? Has anybody ever showed up at your plant and said, I need 5,000, 10,000, whatever gallons it is, because I need to seed my plant? Usually it's a brand new plant. They want to take some of your bugs and put them in their plant to kind of jumpstart everything. This plant actually, this isn't my picture, but when I did the research, because I pulled this off of a website, there was a white paper about this plant. This is in Arkansas. And the problem with this plant has been online for 15, 20 years. And I said, man, what the hell? Why does it look like that? They had an industrial load come to the plant. PERC. I talked about PERC when we first got here. I said, who knows what PERC is because of this slide? So what's the old adage? A thimble of PERC will kill a 2 MGD plant? Somebody told me that once. I don't know if that's accurate. But basically, an old school dry cleaning company is in this town. They 5-gallon bucket down the drain. These guys ran like this for months before they figured it out was a dry cleaner, because they didn't know there was a dry cleaner in their service area. So they didn't treat anything. They violated every NPDES permit possible. The plant looked, to a lot of people, the plant aesthetically looked like it was running fine until you look at that foam. Step feed, sewage, through an anaerobic process. This is for BNR, usually dropping phosphorus in this area. But basically, if you think about it, the step feed, the sewage is getting put in numerous places, right? Why would we do a step feed process? This is really a pretreatment question. Why would we do a step feed process? Shock?
Yeah,
I mean, it's a good term.
Yeah, to, I guess, even distribution of food.
I like to call it spreading the love.
Yeah, okay.
So from a pretreatment standpoint, step feed is really good if you're kind of a pretreatment minded person and you're going to a plant. If you say you've worked in pretreatment for 15, 20 years and you're like, you know what, I really want to be a plant operator. This would make the most sense to you because you can measure, analytically, you can measure metals concentrations throughout those pretty accurately. So step feed's kind of a cool design. Oxidation ditch. Looks like an oval, extended air. on off. So basically, flow comes in from, well, it looks like this one. The flow probably comes in here somewhere. And literally just hydraulically goes around. And then at some point, there's a weir somewhere on this one. It's just a picture from the Google. A weir will open up and let that flow out once we know it's treated. And that's all operator stuff, right? Stuff you guys don't care about. Aeration. We keep talking about how the hell's it work? Supplied by reactors a bunch of ways. Blowers, brushes, jet systems. So these are blowers. These are multi-stage. This is an old picture, obviously. You guys probably have high-speed turbos. Everybody seen a high-speed turbo? Anybody not seen a high-speed turbo? You gotta say it like that. High-speed turbo is like the coolest invention of all time. If you're a diesel guy like I am, it looks like a turbo on a truck on steroids. And they make some serious freaking power. The problem with the problem I have with high-speed turbos is you can't shut them off. If you shut, they're so tight of a tolerance that you can't shut the air off. At low flow, like when you don't want any more air, you have to like let them spin real slow. St. Vrain, you're St. Vrain, right? No, you're St. Vrain. How many blowers you got?
Right now, like 7.
What's your design flow rate?
6.
6 MGD, they have 7 blowers. What's the lowest you can get your DO to?
1.
What did I say a few minutes ago? I'm not busting your chops. I'll bust Paul's chops all day long. Right.
Yeah, we've destroyed dozens of them.
Yeah.
And we're replacing them, and we're destroying those too because of.
I got any engineers in the house? Yes. 'Cause I love beating up engineers. So engineers love to build stuff that's way too big, and they got to make everything redundant, right? So the problem with wastewater treatment is you got to drive that DO down. You got to starve those bugs. Everybody in Colorado, I don't know if it's Utah, North Dakota, South Dakota, I don't know if you guys are dealing with it too, Wyoming. When you have a design engineer come in, the first thing they do is go, your blowers are undersized, we need 30 of them. Why? It costs money. How much is a high-speed turbo blower? We're talking $1 million, $1.5 million per blower. So if you put in a bunch of blowers that you don't need, they made a bunch of money, you can't shut your air off. Who's getting hosed? You can't denitrify fully. Can you meet Reg 85, Reg 31 in Colorado when you can't denitrify? Not a chance in hell. So now what do? We call that engineer back up and say, hey man, my blower's too big. Yeah, that sucks. Hopefully you get some more flow. Well, I'm not getting any flow for a while. What do I do now? Well, let me sell you this chemical addition package, right? That's what they always say. We'll add some ferric, we'll add some synthetic kind of chemicals to make sure you're carbon limited or carbon rich, not carbon limited. Have you heard this? See, I'm not talking out of my butt here, guys. Here's some methanol. What's the fun thing about methanol? It explodes. That's fun. I live in Red Feather Lakes or near Red Feather Lakes. We're getting shoved out of Red Feather all the time because of burn. We got forest fires all the time. I have 6 wastewater plants up there. All of them use methanol. My ass is getting the hell out of a wastewater plant when there's a fire coming, right? Okay, so blowers, multi-stage centrifugals, old school, still work. High speeds is kind of the new technology, super cool technology, but somewhat limiting. I talk about brushes. Boxelder has an oxidation ditch made by Kruger, which is basically a motor that runs a giant brush like you see on the front of like a street sweeper. Everybody seen a street sweeper? It kind of looks like that. And all that's doing is introducing oxygen, making some turbulence. Jet systems. Anybody ever heard of a jet system? Jet techs. So jet systems is a simple, really cool design, old tried and true design. Basically a centrifugal pump. Everybody's seen a centrifugal pump. Instead of the standpipe going up to like pump the water out, it goes into a little nozzle and it introduces air. So as the water flows through the nozzle, there's a hole in it, an orifice plate, and that air is sucked in and creates oxygen. What's the cool thing about a jet tech system in a B&R process? Anybody? If I plug the hole the orifice plate in that pump, am I adding oxygen? But am I mixing? Cool, huh? That's all it is. Mix, aerate, mix, aerate. That's how you get complete biological nutrient removal. Very, very simple. Just how do you do it at your plant, right? Fine bubble and coarse bubble. What are the differences? Not you. What's the difference between fine bubble and coarse bubble? This is not sciencey at all. Somebody yell it at me. Fine bubble. Yeah, I said that. Oh, size of bubble. Size of bubble. Yeah, exactly. So in an aeration system that we're doing wastewater treatment, do we want a fine bubble or a coarse bubble? Why? Surface area. Does that make sense? You get one big ass bubble, you got this much surface area. If you have a billion tiny little bubbles, you got more surface area, right? When is a big bubble pretty cool? Mixing. Where else? What's that? What part of the process is really cool for a big bubble? Digesters. Is that you again? Who said? Oh, his sidekick. Digesters. Digesters. We don't really. So a digester, if we think about it, we'll get to it. You think about a digester, it's our bugs that we don't want in the plant anymore. We have no more use for them. So we ship them into a digester. We want to feed them just enough oxygen to keep them alive. Why do I want to keep my bugs in my digester alive? Further breakdown. What is that technical term?
Volatile solids reduction.
What's the volatile solids reduction is what he said for those of you that couldn't hear him. And what does the EPA say we have to have? How many percent volatile solids reduction in a digester before we can land apply the poop?
I think it's 40%.
38, close. 38% volatile solids reduction in a digester before you can land apply it. So, if there's very little food, because it's just a bunch of bugs in a digester, and we're giving them a little bit of oxygen, how else are they eating? How else are they consuming something to get volatile solids reduction? They're consuming each other. Cannibalistic little bastards. Endogenous respiration. God, that's awesome. They're eating each other. What's the byproduct of a bug eating another bug? H2O. So what happens in an aerobic digester? Sorry, I should have clarified that. We're talking aerobic digesters here because we're talking about bubbles. In an aerobic digester, if a bug eats another bug, I got more water, right? So I got some volatile solids reduction. I got a bug reducing another bug. But now I have water. What do I do with that water? I decant it. I send it back to the front of the plant to treat that water again. And what did I do to my digester? I reduced the volume. So I had 1 billion gallons of sludge, let the bugs eat each other, that goes to 900 million pounds of bugs, let them eat some more, 800 million pounds of bugs, but we're always feeding it, right, with a little bit of oxygen. So that's how we get our volatile solids destruction. Clarifiers. We made it through the headworks, we're into the reactors, the wastewater, it's treated now, right? Went through the headworks, got the magic, the bugs are in it, now we're in the clarifier. What happens in the clarifier? We talked about it a little bit. Slow spot in the road. Let them settle. Let my bugs settle. Clarifier basics. If you've never seen a clarifier, basically the mixed liquor, say your aeration basin's over here, there's a pipe, falls over the weir, goes into the bottom of this guy, and just hydraulically forces itself up the hole. And this is called a what? Where's my operators? Stilling well. What is a stilling well for? I've got mixed liquor, brown stuff, heading into a tank, and I've got this ring around it. What happens if the ring isn't there? Bingo. I got to slow it down. That flow is going to come in here from the aeration basin. And if these rings weren't here, it would literally just go in and just float out, go straight out the weir, right? So right now, what it does now is mixed liquor comes up, hits this, hits a wall, kind of slows it down, right? What happens when solids slow down? So then they come out these little holes, and they hit this wall. What are they doing then? Right? So all of my sludge, my bugs, my good bugs are at the bottom of this clarifier. The top is water. We have these the baffle that basically any kind of scum, fog, anything like that that floats that we didn't treat or get rid of in our primary and secondary process, it's going to stick here. This arm is going to go around, and there's a beach. We call it a beach. Basically, this thing runs around and collects all that crap off the top of the surface and just runs it into this beach, which goes back to the plant or to the digester or something to be treated again. So essentially, when you get to the clarifier, that's where you should have clean water. But you still have bugs in it. They're just on the bottom of the tank, right? Normal and bulking. This is what your clarifier at your plant should look like. If it looks like this, quit. Legitimately. Now, I'm going to get nerdy a little bit because I've got time to be nerdy. What happened here? Why does it look like that? Denite. Why? Keep talking to me, boy.
It sat too long in the bottom.
Yeah, just sat too long.
What happened in the bottom of that tank? You said it.
I did.
Denite. What caused that poop to come to the top? Nitrogen gas. Okay, so if I converted ammonia to nitrate to nitrite to nitrate, nitrate's a gas, right? But I didn't denitrify. I just nitrified. Ammonia, nitrite, nitrate. That's where I stopped my treatment. Never shut the air off in the aeration basin to actually denitrify. My clarifier is the first spot where I actually have absence of oxygen, right? So now I've just got a bunch of nitrate, a gas, hanging out in the bottom of a clarifier with a bunch of poop on top of it. I don't have to get real sciencey when I say what happens when gas floats. All that sludge comes up, right? So, who runs a 2-foot blanket in their clarifier? Who knows what I'm talking about when I say 2-foot blanket? Everybody following me on the blanket? How much sludge you have in the bottom? You run 2 foot?
We do, but it's inconsistent sometimes.
Yeah, that's always going to be instant. Who runs more than that? Good. Who runs no blanket? Why? We're going to fight. Come on. Hold on, I can't hear you. I got to know. I got to know the no blanket guys.
So we just do it in case we get a load in or something, and we have the space then to put it. Because we only do that in the summertime. In the wintertime, we'll run a blanket.
Okay.
But I mean, it just puts the MLS back into the bioreactors.
Mm-hmm.
So it's not a problem for us to do.
Where are you at?
Bozeman.
Bozeman. Okay. Montana boys. All right. So, in 15 years of teaching plant stuff, he's probably the third guy to say no blanket. His reason's decent. Most guys tell me, we don't run a blanket because we were told not to run a blanket, because they don't want to deal with bulking. His reason was not because we're scared of process control. His was, we have a weird diurnal flow. Winter we run a blanket, summer we don't. Totally good. I'm not going to argue with him. I'm not going to find him out in the parking lot later. We're good. But the guys that say we run a blanket, we don't run a blanket because that's the way we were told to run the plant, ridiculous. If you think about a blanket, which we're going to get into, RAS and WAS, return activated sludge. So now I've got bugs at the bottom of this clarifier, and I need some of them. And now they're hungry. They haven't had any food for a while. I'm going to send those bugs back to the front of the plant and have them do the work again. That's where that MCRT comes from. How many times do I circulate that bug through the plant? Guys that don't run a blanket don't have this control. Basically, when there is no food or there's no bugs left to treat the amount of food coming in, these guys are hosed. Unless you're like this guy back here from Bozeman and knows what to do. But most people, when they say they don't run a blanket, it's literally because they were told not to. They have no other idea why not. So RAS, we got a good concept of RAS. Bugs settle to the bottom of the clarifier. I send some of them back to the front of the plant to work again. Again, pre-treatment. Toxic environment in the A basin leads to toxic environment in the clarifier, which means I send essentially dead bugs back to the front of the plant. Useless, right? Not doing any treatment. Mixed liquor return and internal recycle. Who's heard this? I know it's some of you, just because I know your plants. Internal recycle. This is essentially a pump at the bottom of the aeration basin that sends the flow back to the front of the plant, and usually at 300%. Jessica knows for a fact that I'm not a fan because you're screwing with the biology. It works to some degree, but it's usually the mixed liquor return or internal recycle is literally a tool that an engineer came up with to not make you denitrify, to make the operator think less, to make them literally, here's a pump, turn it on at 300% of your influent flow, and it will send the bugs back through your plant so many times that they will just have to be in contact with nitrate, and they'll denitrify. But what's that do? Costs money. If you're a pre-treatment person and you had a slug load come to the plant and you send it through the plant 300 times, what's that do to your plant? Screws it up. Again, from an engineering standpoint, it makes sense. From a pre-treatment plant operator standpoint, it's probably one of the worst things you can do for a plant because you're just recycling toxic crap through your plant. WAS, waste activated sludge, these are the guys that we don't need anymore. We like to keep our mixed liquor at 2,500 milligrams per liter. We ran a filter today, found out it was 2,800 milligrams per liter. We're going to do a calculation on how many pounds that is, and we're going to waste that amount of pounds to a digester. We don't need those bugs anymore. New bugs are coming in. Good? Disinfection. Can kill a virus or sterilize. Which one kills, which one sterilizes? I should have like a things fly in. Chlorine kills, UV sterilizes. We talked about disinfection a little bit earlier. Okay, so chlorine gas, everybody's seen the 150-pound cylinders. These are calcium hypochlorite pucks, UV, sodium hypochlorite solution. I always make the joke, and I think with our current world, I probably should not make the joke, but we're in Wyoming, so I'll do it anyway. One more reason why I hate gas chlorine is anybody working, there's a Metro guy in here. Denver Metro, I mean, you guys are all familiar with it. If I was a terrorist, how could I take out Denver without even getting near Denver? They have rail cars of chlorine. If the wind's blowing towards Denver, how much heavier than air is chlorine gas? Jessica? 2.5 times heavier than air. So it's this hot, right? So if I were to blow up a few rail cars with the wind blowing towards Denver, did you? Thank God. There's a lot of people still running rail cars. But that's my point. Like it's a safety concern. I don't like dealing with it. My employees, I don't want them dealing with it. And it's just all in all, it's bad. UV sterilizes your bacteria. It's not killing them, but they can't reproduce. So much safer. Ancillary. I thought I'd be running out of time, so aerobic digesters we talked about. Anaerobic, those are those big dome-looking things with a lid. Heat and absence of oxygen or anaerobic conditions. That's how they do the volatile solids reduction. DAF, if you guys have worked in the pretreatment world long enough, I'm sure you've seen a DAF at a pretreatment, at a categorical industrial user or significant. Who was I talking to earlier? It was from Wisconsin. You've seen a DAF, huh? Dairies use DAFs all the time. Okay, we're floating the solids and then the liquid streams going to the wastewater plant. RDTs, we talked about them. Screw press and centrifuge. I own a centrifuge. I own the only centrifuge on a trailer in like 19 states. If you're at a big plant, you've got a centrifuge probably. Screw presses are pretty cool. Has everybody seen a screw press? Kind of a new technology. Really, really low energy, but basically works like a centrifuge, dewaters that sludge out of a digester. Tertiary treatment. Anybody use tertiary treatment? Got it. No. Anybody have tertiary treatment? Filter their effluent? Yeah, that's pretty cool. Has everybody been reading the magazines about direct potable reuse? Man, don't get me started. I am so excited. Let's do it. BNR, I kind of went through all this. They're rushing me out of here. Okay, so are you giving the slides to these people? If you are an operator and you don't know this Gantt chart, or if you're just a pre-treatment person that wants to know more about wastewater treatment, this is BNR in one slide. Know that. If there's anything that I walk out of here today, know that. IFAS and MBR, some people have heard about it. I'm getting shaken down. Hollow core membranes, man, all the fun stuff. Side streams. So this is where I wanted to get to before they kicked me out. Side streams. Centrate, filtrate, pressate. As a pre-treatment person, you don't ever see this. But this is something that will directly affect your removal efficiencies. When you're doing your local limits development, you're thinking about how much, I don't know, ammonia, zinc, whatever. You're thinking heavy metals. All your heavy metals end up in your digester, they should. When you dewater sludge from your centrifuge or from your digester through a centrifuge or a press or whatever, those metals are they're bound in the sludge, but some of them go into soluble form. So when I do local limits, when I do local limits, a lot of times I try to get samples directly from my centrate or filtrate, so I have kind of a constant. I know that this is the contribution to the wastewater plant that's kind of a side stream. It's kind of a fun little calculation to work with. Digester decant, we talked about the supernate. And I really wish I had more time because I'd get into water plant residuals. There's a new rule called the T-norm rule. Anybody heard about the T-norm rule? It's going to kill us all. It is going to kill us all. They don't have the science. They're still trying to put on regulations. If your water plant in your district or your town discharges to your treatment plant, you are going to have a hell of a time getting rid of your biosolids. In Colorado, there's a place called Clean Harbors that will take dead bodies if you want them to. They will not touch water plant residuals right now. Just food for thought. Oh, I had a question. Who has a permit for their water plant in the service area? Who has a water plant in their service area and permits them with an industrial pretreatment program? Sorta? I wish everybody in the room would raise their hand because this is going to be a big deal pretty quick. Jessica works for me. Jessica was over at a city here not that long ago. They plugged up their pipeline going to the wastewater plant from water plant backwash. And how thick was that scale in the manhole? 3-4 inches of just goo that they scraped off the walls of a manhole. And nobody could tell us how long it's been there. All right, that's it. So just remember, this is kind of how I always close out my sessions. Wastewater treatment is the only science in the world that has no control of what comes in, but must have a perfectly defined output. Make sense? Unless you're pre-treatment. Then you have control. You control it at the source. You can't control the domestic population. But if you remember that the treatment plant operators, they're dealing with a science project every day. If you can help them with that science project, help them. Know your operators, know your collections department. That's all I got. Thank you.